Welcome back to the lair.
Yes, it's another episode of Informational Videos for Freshmen.
But we're not teaching freshmen today, are we?
Nope, we're graduating.
Huh?
We're teaching seniors.
And what are we teaching them?
Physics, of course.
Physics.
Yes, physics. We're going to teach you how to do some basics you'll need for electronics.
And what is this alien device?
It's a multimeter.
Okay. Well, I have about as much clue what's going on here as a dead dodo, which most of them are dead. So why don't you help them while I go make a coffee run?
Sounds reasonable. Alright, so this is a multimeter. As its name implies, it can measure a whole plethora of things. It can measure the resistance of a circuit, voltage, amperage, temperature if you really wanted to. Don't know why. Say if you were hot, you could measure the temperature. I'm getting off track here, but it can do that. It can measure whether your circuit's continuous or not. And you might be wondering, how can a little box with a couple prongs sticking off of it do all these things? You just asked yourself a good question. I'll show you.
A word of warning to you guys. Even though the device you're working with looks relatively harmless, it can still kill you. The prongs are sharp, and while your epidermis is very resistant, the inside of your body is not. And if they get under your skin, you can suffer from internal burns, or even an acute case of IDS. Do not play with electricity. Ever.
Okay, so with that out of the way, today we're going to be building this light bulb circuit. It's a light bulb circuit with a dimmer switch, and as you know, the circuit must consist of three things. One, power source, i.e. this thing. Two, we need wires to get the current to travel through. And three, we need a component for the current to do work on when it's actually there. I've got this circuit assembled before, and it's finished cooking now, so I'll get that out of the microwave. Quick popcorn. So now that we have a working circuit, we can get to measuring it. The first thing we need to measure is the continuity of the circuit. I mean, this is important because, if we didn't turn it on, we would want to know if our light bulb was burnt out. So what we're going to do is we're going to take our multimeter and we're going to set it to this little musical note thing. We're going to turn it on and we're going to test that it's working. So it's going to beep if it works. So it works. So basically, when there's a current between these two prongs and they're connected, it's going to send a current through and it's going to beep. So what we're going to do is we're going to disconnect this component from the circuit to make sure it works. We're going to attach one prong to one wire, like so, and we're going to attach the other prong to another wire, like so. And it beeps. So the light bulb works. Not that we didn't know that, but say it didn't turn on while testing. We could check to make sure that the light bulb wasn't out. So now you know how to do continuity. So to measure voltage, it's pretty simple. What you're going to do is you're going to set your voltage meter up to volts in the DC, not the AC. And you're just going to keep your red prong plugged into this outlet. You're going to turn on your meter, and it's going to read 0 because there's no current flowing through it. What you're going to do is you're going to make a break in the circuit, and you're going to measure the voltage across the break in the circuit. So, like so. Now, the meter is set to 2, which means that it can measure a maximum of 2 volts. So, this is 9 volts. We already know that because that's what I set the power supply to. So, which means that it's just going to read a 1 if I connect it to the circuit. So, what we're going to have to do is we're going to have to ratchet up the maximum number of volts it can do. We're going to take it to 20 volts. And we're going to measure again, and we should get around 9 volts of current flowing through. And we get, it's floating somewhere around 9 each time we connect it. Don't worry if you get it backwards, so it'll just read a negative number, but that's fine because you just take out the sign. Alright, now we know voltage we can measure resistance and amperage. Measuring amperage is similar to measuring voltage, but we must remove the red prong from its slot. See, this is marked volts, ohms, and hertz, and we got to put it in the amp slot. Don't ask why. I'm sure your teacher will explain it to you later. But anyway, that's what you have to do. You also have to adjust your meter, so you have to take it from volts to amps DC. And it goes from 2 milliamps to 10 amps. You shouldn't really need 10 amps, that's actually quite a lot. We're going to measure across a component in parallel, as opposed to in series when we made a break in the circuit. We're going to turn on our meter, and we're going to measure across the component. So we're going to measure across the light bulb. So we're going to put one prong here and one prong up here, and it will give us a value. Now, the other thing you need to worry about is that I believe my meter is too sensitive, which means that I need to it's not sensitive enough, which means I need to ratchet it down to 20. We'll measure across here, and again with the negative sign. I just have it backwards. You can take off the negative sign if you want. You can flip your prongs around. It doesn't really matter. Both methods are valid. It all works out anyway. Measuring ohms is pretty easy. You just have to set your meter to measure ohms. It can measure anything from 200 ohms to 200 mega ohms. If you know your metric prefixes, you'll know that that's actually quite a large amount. Turn your meter on, plug it into the ohms slot, and measure across a component like you did with the amps. Now you'll see the ohms is not sensitive enough there, so I need to ratchet it up a little bit, and it's too sensitive there. Too sensitive. Still too sensitive, so I'm going to go down to 200. And you'll see that we get 4.1 ohms going across this light bulb. So that's pretty simple. It's not hard to measure anything in the circuit. You just have to know how to do it.
So that wasn't that bad, was it?
Actually, it kind of was.
Oh, sorry about that. Hey, we've done biology before, and I had no idea what was going on there.
I guess it's just the sacrifices we make for science.
True. Do you have that double frap explosive latte I ordered?